This question comes from your mid-chapter review. So it starts out, 2 white marks are made on a car tire by a parking meter inspector. 1 mark is made on the outer edge of the tire. The other mark is made a few centimeters from the edge. The 2 graphs show the relationship between the heights of the white marks above the ground in terms of time as the car moves forward. The first part, what is the period of each function? So when we look at period, we need to look at the time it takes to do one complete wave. So looking at our graph, we can see that for Mark 1, a wave would take from 0 to 0.25 seconds. So the period is 0.25 seconds. For Mark 2, looking at the red curve, it's also 0.25 seconds for one complete wave. That's the period. Now looking for the equation of the axis of each function. So now we're going to look at the axis. So here's the axis. For Mark 1, the maximum, so the black line, the maximum is 60 and the minimum is 0. So halfway between the maximum and the minimum would be 30. So our axis is y equals 30. For Mark 2, or the red line, we look at the maximum is 50 and the minimum is 10. And halfway between the maximum and the minimum is y equals 30 is the axis. The amplitude is the distance from the axis to the maximum or from the axis to the minimum. So looking at Mark 1, the center line is 30 and the maximum is 60, so the amplitude is 30. Looking at Mark 2, the axis is also 30 and the maximum is 50, so our amplitude then is 20. Now to look at range. Range, like always, is the possible y values or dependent variable values. So for Mark 1, the black graph, the lowest value is 0 and the highest value is 60. So that's our range. For Mark 2, our range is from 10 and to 50. So now to determine the speed for each mark. In order to do that, we need to know the distance covered by the mark in 1 revolution. So we know 1 revolution for the black mark is 0.25 seconds. But how far did that actually go? So the mark goes entirely around the tire. So if you think about it starting at the bottom and going entirely around the tire, we need to find that distance, and that's really just the circumference of that circle. So we need to find the circumference of that circle. We know that in order to find the circumference of that circle, we need 2 pi r. The radius is equivalent to the amplitude in this case. So the amplitude for the black mark, or Mark 1, is 30. So this would be c equals 3.14 times 30. So the distance for Mark 1 is 188.4 for 1 complete revolution. In order to figure out the speed, we need to figure that over the period. So the 188.4 centimeters in this case is over the course of 0.25 seconds. So the speed then is equal to 188.4 over 0.25 seconds. So in this case, it's 753.6 centimeters per second for Mark 1. For Mark 2, we're going to find the speed as well In this case, we have C, the whole circumference of the circle, because the mark will travel around the entire tire. So that's 2 times 3.14, and the radius for the second one is the same as the amplitude, so 20. The circumference for this tire, or this mark on the tire, is 125.6 centimeters. To find the speed then, we'll use that number and divide by how long it takes to make a complete revolution. So because it has the same period, we're going to divide again by 0.25. Giving us an answer of 502.4 centimeters per second for the second mark. I'll leave the last part for you. Good luck.